Okay, so hello, it is me this week, and I want to just talk pretty briefly about one little feature, I suppose, of Python, or more to the point, one little thing where you can overlook what you're actually doing in a way that can be confusing to look at and can lead to bugs and unexpected behavior, even though if you look at what's going on, you see that it's actually exactly as it should be and easy to understand. So I'll start by saying the motivation for this is a sort of discussion we've been having as RSEs about what kind of typing idiom Python uses. So most languages can be described as either strongly typed or weakly typed. And strongly typed means that everything has a type, like it's a number, it's a string, something like that. And weakly typed means that things can change types. So at one moment it might be a number, and at another it might be treated as though it's a string. And in most languages you've got some way of producing a new thing from an old thing with a new type, and that's perfectly consistent with a strongly typed language. Your thing is a new thing, it's just built from something of a different type. But anything where a thing can change type is technically this thing called weakly typed. Now Python is a little odd to discuss because while data items are a kind of strongly typed thing, a number is always a number, one is always a number, it can't magically be a string, although you can make a string containing the same idea of one. You see why this is a bit of a complicated discussion. The trouble with Python though is it makes it incredibly easy to relabel a piece of data, or indeed put a new piece of data behind the label. So I'm going to show a thing that might look at first a little surprising, but when we go through it we'll see actually it makes perfect sense. So what I'm going to do is first I'm just going to demonstrate this typing thing, because I may as well, I'm here. So I'm going to make a variable a and I'm going to set it to 1, and then I'm going to look at what its type is. It's an integer, right? That type says what type is this, is an integer. And now I can do a equals 1, check its type, it's a string. Now, something there has changed the answer to what's the type of a. It's mildly important to keep in mind that what we've done is point a to some new data and ask what type is the data that a points to. Niche in most senses. For types, particularly niche, because a lot of people would encourage you to think not in terms of what type something is, but in terms of what its capabilities are. But that idea of repointing a, making a refer to a different bit of data, is very important. So here's the surprise. Let's make a list of 4 numbers and store that into this a. Now let's make a second list b that is going to be that is going to be a copy, another reference to this list. B equals a. B and a are labels for the same data. If we check, are they equal? It is true, they are equal. If we check, are they the same? It is true, they are the same object. They are referring to the same object. So now let's say we want to add some more data into our list A. So we do it by adding some more data to our list A. Okay, we do that. Okay, now let's look at A. There we go. A is what we thought. It now contains not only 1 to 4, but also the numbers 5 to 8 as well appended onto that. And that's exactly what we think. So a moment ago, A and B were the same. It's not anymore. Because on that line, we did A equals something, and A equaled a new object. We've repointed A to a new object, and if we look at, well, I mean, obviously A equals B is going to be false. We've just looked at them, they are not the same. If we look at, are they the same? No, they're not. Good. I really hope they're not, because otherwise something has gone very, very strange with causality. But maybe we didn't realise what we were doing there was pointing A to something new and breaking this connection between A and B. Maybe we should have realised that. We certainly noticed that we've assigned A to a new thing. But here's the surprise. In most languages, A equals A plus something has a nice shorthand way of saying it. So let's set A back to equal to B. And let's try, rather than doing it that way, we're going to use this nice little shorthand of adding on to A. I'm going to do it like that instead. Plus equals and equals A plus something, usually they're the same thing. So, alright, A is what we thought it was. This time, so is B. Because in this case, for lists in particular, they are the same, cool. And if we do the are they the same, they are the same. They not only contain equal data, A and B are the same reference. They refer to the same piece of data. And that's because for lists, plus equals is not the same as this other idiom, this one we used previously, the add on something new. When we use the plus equals, we modify in place. We don't make A refer to a new piece of data. We take the same piece of data we always had and we modify it. And that's modified B for us behind the scenes as well, because A and B are the same, different names for the same piece of data. And in this case, we never broke that connection. And it's just a little bit surprising coming from some languages, because plus equals is supposed to be a simple shorthand for, adding something on. It's supposed to have exactly the same meaning as that previous line. For lists, it doesn't. And that could well constitute a bit of a surprise, although if we think it through like this, maybe we see, well, actually, yeah, we maybe should have spotted that. So really, not a lot to say, other than that. Maybe that surprises you, maybe it doesn't. Maybe you've got a little bit to think about what assignment really does in Python, and we do like thinking of that sort of labeling of data. It's quite a helpful one for a lot of stuff you deal with in Python code, because you're just giving a name to a piece of data, and it can help in some circumstances. Now I'm going to try and do this on the fly, so this might not work, but let's give it a shot. Okay, and so what we've done there is make an A and a B and give them both the same numeric value. Now, nothing we've done there really tells us that they should be the same data object, right? They're a number, it's the same number, but we never connected A and B together in our mind. And we really hope that, they're not connected, and they're not. Their data items are, because if we change A, we really hope B isn't going to change just because we set them to the same value once. And that's true. That's perfectly true. But behind the scenes, Python's only making one object that is the entity 156 for us. So A and B end up being in some sense the same for a little bit. Now this, I'm just going to try and see what happens. There we go, it does work, I can do it on the fly. We did the same thing, but we chose a different number. And now they're not the same, and they're not connected in this odd way. The reason, believe it or not, is that there's this kind of little optimization thing. For small enough numbers, Python wants to go, oh, I only need one copy of that. Does the same for things like non, does the same for some other small values. But once we get above, it's probably 256, I'm not going to go check it to see. Once we get above that, it doesn't link those data items together at all anymore, and we get a different one. And it's just one of those weird little oddities where, because of the way that Python has labels for data, and because of the way this is operator works, which is, are these two labels for the same piece of data, we can get slightly odd looking things like this, where depending on what the data is, they may or may not be the same. What this really tells us, though, is that this is idiom is something that we should really handle with care, because we ought to think very carefully about what question we're asking. Most of the time, what we really want to know is, are they equal? Do they have the same value? is do they label the same data? And in the case of numbers, that's a bit of a weird question. In nearly every case with a number, what you mean is, are they equal? And you can get a really a really fun one. Luckily that was a comment character, so it didn't go wrong. Because there is only one non-entity, and non is the kind of, nothingness. It's not a number, it's not a string, it's not an object, it's nothing, it's a non. There's only one of those in a Python interpreter. So if we set two things to both be non, suddenly they're the same as each other in this weird way. Don't want to imply that this is complicated and weird and important, just want to point out that you've got to be careful when you're inquiring about what something is. Most of the time, what the question is rather, are they equal? And we'd hope that non is equal to non, probably, and we'd hope that 300 is equal to 300, and we hope that lists are equal to each other. All of those things true, but if we inquire about things in the wrong idiom, we're going to get some little surprises. So maybe there was something interesting there, maybe not, but I thought it was interesting. So hopefully we will be back soon with another one of these videos, and thanks for listening.